Hi, this is Halal. In this video on mathematical economics series, we will learn how to solve a market model using algebraic method, using inverse of a matrix method, and using Cramer's rule. So this numerical we will solve by three different methods. The first method is the algebraic method. So the question is, given the market model where D is equal to 66 minus 3P, where D is demand and P is the price. Similarly, S is equal to minus 4 plus 2P, where S is the quantity supplied and P is the price, and D is equal to S, where demand is equal to supply. That is, quantity demanded is equal to quantity supplied. Find equilibrium, price and output. So we will solve this very question using the algebraic method, and after that we will use the inverse method, and after that we will use the Cramer's rule method in solving this question. So the first method is the algebraic method. Now this algebraic method is very simple. What will we do? We will let this be equation first, let this be equation second, and let this be equation third. Now what will we do? We just put the value of equation first and second in equation third. That is, we put the value of demand and supply in equation third. That is, put equation first and second in equation third. So and this will become, now D is equal to 66 minus 3P. So in place of D I will write 66 minus 3P. So this will be 66 minus 3P, which is equal to, now S is our minus 4 plus 2P. So I will write minus 4 plus 2P. Now solving for the price. Here I will write 66. Now I will took this minus 4 on LHS. So this will become, when transposing to LHS, this will become plus 4. This is plus 4. Now I will write this equality sign, and I will take, here it is 2P. So I will write 2P, and I will transpose this minus 3P on RHS. So this will become minus 3P will become plus 3P. So I will write here plus 3P. So this will become 66 plus 4 is equal to 70. So I will write 70 is equal to, now 2P plus 3P is equal to 5P. So I will write here 5P. So we can write this as 5P is equal to 70, or P is equal to 70 divided by, now here it is in multiplication, when transposing this will become the denominator here. So this is 5. So now this is 5 ones are 5. Now this will become 20. 5 fours are 20. Therefore our equilibrium price is, so I will write here P is equal to 14. So this is our equilibrium price. Now we will put the value of P in either of the first two equations. That is, put P is equal to 14 in either of the two equations. So we will place this in equation first. That is, in equation first. Now here D is equal to 66 minus 3, and here it is P. So in place of P we will write this 14. So this is here 14. So this will become 66 minus, now 3 fours are 12, 3 ones are 3, which becomes 4, or D is equal to this, implies D is equal to, now subtracting 42 from 66, now 6 minus 2 is 4, and 6 minus 4 is 2. That means this demand is, this D denotes the quantity demand. So this D is the quantity, implies equilibrium quantity is 24 implies this means that our equilibrium price is 14 and equilibrium quantity is 24. So this is the algebraic method. Now we will solve the same question using the inverse of a matrix. Now we will solve the same question using the inverse method. So the question is given the market model is D is equal to 66 minus 3p, S is equal to minus 4 plus 2p, D is equal to S. Find equilibrium price and quantity using the inverse method. Now first of all, what will we do? We will transpose all the endogenous variables on the LHS side and the exogenous variables on RHS side. That is, the solution will be, these are our equations. So we will transpose the variables on LHS. That means D plus 3p is equal to 66. Similarly, S here it is plus 2p, it will become minus 2p is equal to minus 4, and here also D minus S is equal to 0. So the first step is to take all the endogenous variables on LHS side and all the exogenous variables on right hand side. Here the endogenous variables are D, P and S, and exogenous variables are 66 minus 4, 0. Exogenous variables are the variables whose value is fixed, whose value is not determined within the model. So this is already given to us. After that, we express this system of equations in matrix form. That is, in matrix form we write this as A x is equal to B, where A is the coefficient matrix, the coefficients of the endogenous variables, x is the solution vector, and B is the vector of constant terms. So we will form this like this will become the coefficient of D. First of all, we write the coefficient of D. Here it is 1. Coefficient of S is not here present, so this is 0. And coefficient of P is here 3, so I will write 3. Similarly, the coefficient of D here is not present, so it will be 0. The coefficient of S is 1 and the coefficient of P is minus 2 here. Similarly, here the coefficient of D is 1, the coefficient of S is minus 1, and here no P is involved, so the coefficient is 0. So we have to write the coefficients in order. If we write the coefficient of D first, then S, and then P, we have to follow the same order. So this is a coefficient matrix. A is equal to this coefficient matrix. Now our solution vector is D, S, P. That means we have to find these demand, supply, and demand quantity, supply quantity, and equilibrium price. And our B is here 66 minus 4 and 0. So this was the first step to express the given system of equations in matrix form after taking all the endogenous variables on left hand side. After that, we take the determinant of this coefficient matrix. This is A, the coefficient matrix. So we take determinant of this matrix, which is the coefficient matrix. So determinant is calculated as we have seen in earlier videos. So we take the first element positive and multiply it with these 4 numbers, because we delete the row and the column in which this element appears and take determinant of remaining elements. That is 1 zeros are 0. Now we have minus. Now minus 1 into minus 2 is plus 1. So it is here minus 1 into minus 2 is minus 2, that is plus 2. So we get here minus 2. Similarly, here we have 0, because the sign of first element is positive, second is negative, third is positive. So I write 0 and delete row and the column in which it appears, take determinant of remaining elements. So we delete this row and this column and now multiplying the remaining elements. That is 0 into 0 is 0, minus 1 into minus 2 is minus 2, that is plus 2. Similarly, here it is plus 3 now. Deleting row and the column in which it appears and take determinant of remaining elements. That is 0 into minus 1 is 0, minus 1 into 1 is 1. I have actually explained this whole stuff in earlier videos, you can check there also. Now which is equal to, now 1 into minus 2 is equal to minus 2, minus 0 times anything is 0, we know. Now 3 into minus 1 is minus 3, which is equal to minus 5. So our determinant is minus 5. After that we have to form the cofactor matrix. We have to form the cofactor matrix. The cofactor matrix is formed by, so I will write here, the cofactor matrix is denoted by C, which is equal to the, so this will become a big matrix actually in space. Now cofactor, so I will write this C here. Now the cofactor matrix is formed by, that is, the cofactor of the first element is, we mentally delete the row and the column in which it appears and take determinant of remaining elements. That is, the first cofactor is 1 minus 1, 2 minus 2, 0. So this is 1 minus 1 minus 2 and 0. Similarly, the cofactor of this 0 is, we delete the row and the column in which it appears, this row and this column, and take determinant of remaining elements. That is 0, 1 minus 2, 0. So I will write here 0, 1 minus 2 and 0. Similarly, the cofactor of third element is deleting row and the column in which it appears and take determinant of remaining elements. That is 0, 1, 1 minus 1. So I will write 0, 1, 1 minus 1. Similarly, the cofactor of this element is, we mentally delete the row and the column in which it appears, this row and this column. So we are with 1, 1, 3, 0. So I will write 1, 1, 3, 0. Similarly, the actually I have to find the cofactor of this 0 here. So we delete this row and this column. So we are with 0, minus 1, 3, 0. So this is 0, minus 1, 3, 0. Similarly, here for this one we delete the row and the column, we get 1, 1, 3, 0. So I will write here 1, 1, 3, 0. Similarly, here minus 2, we delete this row and this column and take determinant of remaining elements. That is 1, 1, 0 minus 1. That is 1, 1, 0 minus 1. Similarly, here delete row and the column, we get 0, 1, 3 minus 2. So I will write 0, 1, 3 minus 2. Similarly, this, for this the cofactor will be delete row, the column, we get with 1, 0, 3 minus 2. So I will write 1, 0, 3 minus 2. Similarly, for this 0, we delete this row, this column. So we are with 1, 0, 0, 1. 1, 0, 0, 1. Now this is not the cofactor matrix, because we have to give the proper sign to the determinants which we have formed. Now the sign of each determinant is actually given by a formula. That is, if this is the first element which is denoted by A1, 1. Now the sign of this first cofactor is given by, that is, minus 1 raised to the sum of the subscripts, that is 1 plus 1, which is equal to minus 1 square. So this is minus 1 raised to an even power is plus 1. So here the sign will be positive. Similarly, the sign of this cofactor, this determinant is, that is we see the position of this element, so it lies in A12 position, that is A12 position. So we write A12. Now formula is -1 raised to the sum of the subscripts 1 plus 2, which is equal to -1. 1 plus 2 is 3. Now -1 raised to an odd power is -1. So here it will be -1. Similarly here it is A22. The sign here is given by, that is this is A11, A12, A13. So A13, here the sign will be -1 raised to the sum of subscripts 1 plus 3, which is equal to -1 raised power 4. Here it is even, so this is positive. So the sign is here positive. Similarly it will be negative, positive, negative, positive, negative, positive. Now this is the cofactor matrix. A cofactor matrix is formed by the minors when giving the proper signs. See, here we can see this is at the position A33. That means it is in the third row and third column. So here positive comes because A33 is equal to -1 raised power 3 plus 3, that is -1 raised power even power. So this is +1. So here the sign is positive. So I was just trying to see, trying to explain how we give the proper signs. Now this is our cofactor matrix. So we will solve this a little bit. Now this is equal to C is our, now here it is positive. Now 1 into 0 is 0, minus 1 into -1 into -2, that is +2, that is 0 minus 2. So here it will be -2, this first element. Here we have the negative sign. Now 0 into 0 is 0. Now -1 into -2, so this will become +2, and we have the sign minus, so this will become -2. I will write -2. Similarly here this is positive. Here the sign is positive. So here it is 0 into -1 is 0. Then -1 into 1 is -1. So we get 0 -1, which is -1. Similarly here we have 0 into 0 is 0, minus -1 into 3, which is +3. So 0 plus 3, but here the sign is minus, so this will become -3. Similarly here 1 zeros are 0, minus 1 threes are 3, 0 minus 3, so we get -3. Here we have 1 into -1, that is -1, minus 1 into 0 is 0, -1 minus 0, that is -1. Here we have again negative number, so negative sign, so minus is plus, so this is positive here. Similarly for this very element we have 0 into -2 is 0, -1 into -3, 1 into 3, that is 0 minus 3, so this is -3. Similarly here it is 1 into -2, that is -2, -3 zeros are 0, that is -2 minus 0, that is -2. Here we have negative sign, so this will become +2. Here 1 ones are 1. Here we have this 1 ones are 1, minus 0 into 0, so this is 1 here. So I will write this is 1 here, that is 1 here. So this is our cofactor matrix. After that we form the adjoint matrix. Adjoint is denoted by adjoint A. Adjoint of this coefficient matrix is equal to the transpose of the cofactor matrix, which is equal to, now since this is the cofactor matrix, its transpose will be, we interchange rows with columns, that is -2 -2 -1, this will become column, -2 -2 -1. Similarly -3 -3 1, minus 3, 1, and here minus 3, 2 and 1, minus 3, 2 and 1. So this is our adjoint matrix, which is the transpose of the cofactor matrix. After that, we use the inverse, that is inverse is equal to A inverse is equal to, this is the formula, which is 1 divided by determinant of the coefficient matrix multiplied by adjoint of A. Now which is equal to 1 divided by, our determinant was minus 5, so I will write here minus 5. Our adjoint matrix is minus 2, minus 3, minus 3, minus 2, minus 3 and 2, minus 1, 1 and 1. Now solving this will become, this is equal to, now this will become 2 divided by 5, this minus minus will get cancel out, so this will become 2 divided by 5. That is, we have to divide all the elements by minus 5. Here this will become 3 by 5, here also 3 by 5, here it is 2 by 5, 3 by 5, 2 by minus 2 by 5, here it is 1 by 5, minus 1 by 5 and minus 1 by 5. So this is our A inverse. This is our A inverse. After that, we know that X is equal to A inverse B. To find the solution vector, we multiply A inverse by B. Now our X is D S B, so I will write here, which is equal to, our A inverse is this 2 by 5, 2 by 5, 3 by 5, 3 by 5 and 2 by 5, 3 by 5 and minus 2 by 5. Similarly, we have 1 by 5, minus 1 by 5 and minus 1 by 5, and we have to multiply it by B. Our B is 66 minus 4 and 0, so I will write 66 minus 4 and 0. So we have to multiply these two matrices. Now the rule for multiplication is that first of all, the number of columns and the number of columns in the first matrix should be equal to the number of rows in the second matrix. Here the number of columns are 1, 2 and 3. Here the number of rows are 1, 2 and 3. Since the number of rows, number of columns in first element matrix is equal to number of rows in second matrix, therefore we can multiply them. So this will become, first of all, we multiply row with column. First row, first column, since there is only one column, so this is 2 by 5, so I will write here, this is I will write actually here, because of the lack of the space I will write here it. So this is 2 by 5, 2 by 5 into 66 into 66. Now 3 by 5 into minus 4, that is minus 3 by 5 into 4. Similarly, plus 3 by 5 into 0, so this is 3 by 5 into 0. Similarly, we write 2 by 5, first row, first column, right? In this becomes the first element. Similarly, second row, first column, so this is here 2 by 5 into 66. I will write here 66. Similarly, we have 3 by 5 into minus 4, so this is minus 3 by 5 into 4, and we have minus 2 by 5 into 0, that is minus 2 by 5 into 0. Similarly, for this is 1 by 5 into 66. This row and this column, we multiply these two, so this will become 1 by 5 into 66. Now here minus minus will become plus, that is 1 by 5 into 4, 1 by 5 into 4, here it is minus 1 by 3 into 0, minus 1 by 3 into 0. So this is our new matrix. Now solving this, we get now here it's 2 into 66, that is 132, that is 132 divided by 5 minus 3 4s are 12 divided by 5. Here 0 into 3 by 5 is 0. Similarly here 2 into 66, this will become 132 divided by 5 minus 3 4s are 12 divided by 5. This is second element. Similarly 1 by 5 into 66, that is 66 divided by 5 plus 4 divided by 5. Now solving this, now 132 minus 12 is 120. Now 120 divided by 5 is 24. So I will write the first element is 24. Similarly 132 minus 12 is 120 divided by 5, that is 24. Here 66 plus 4 is equal to 70 divided by 5, which is equal to 70 divided by 5 is equal to 5 1s are 5, 4s are, that is this is equal to 14. So this is 14. That means our DSP, demand, supply and price, quantity demanded, quantity supplied and the price are in equilibrium at 24, 24 and 14. This means quantity demanded Q is equal to 24, quantity demanded supplied is 24 and equilibrium price is 14. Implies Q equilibrium quantity is, that is quantity demanded and supplied, which is 24 and equilibrium prices, that is 14. So this is how we use the inverse method. So I will repeat here. First of all, we express the given system of equations in such a way that all the endogenous variables are on LHS side and exogenous variables are on RHS side. This is the first step. Second step is to express the given system of equations, this very system of equations, in matrix form by formula AX is equal to B, where A is the coefficient matrix, X is the solution vector and B is the vector of constant terms. After that, we take the determinant of this coefficient matrix. Now the determinant we got here minus 5. Similar, after that we form the cofactor matrix. The cofactor matrix is formed by deleting the actually the cofactor matrix is formed by the minors, which I have explained in detail. That is, the cofactor of first element is, that is, we mentally delete the row and the column in which it appears and take determinant of remaining elements, that is 1 minus 1 minus 2 and 0, 1 minus 1 minus 2 and 0. After that, we have to give a proper sign. Since this very element appears in the position A11, the sign of this is given by, that is, the position of any element is actually given by the formula Aij is equal to minus 1 raised power the addition of subscript, that is I plus j. Here, because A11 is equal to minus 1 raised power 1 plus 1, that is minus 1 square, which is positive. So here the sign is positive. Here this will become minus 1 cube. Here minus 1 to the power 4. So this is minus plus minus plus minus plus, and accordingly we give the sign. After that, we solve this, we get the cofactor here. This is the cofactor matrix. Now adjoint is equal to the transpose of the cofactor matrix. Since this is the cofactor matrix, its transpose is denoted by this C dash. So the cofactor transpose is nothing but interchanging the rows with columns. Since here it is row minus 2 minus 2 minus 1, we form this as columns. Similar is for the other rows, that becomes the columns. So we formed the adjoint matrix. After that, inverse is equal to A inverse is equal to 1 divided by the determinant multiplying this by adjoint A. Our determinant is 1 divided by the determinant was minus 5, and we multiply it with this adjoint matrix after multiplying every element by the determinant, we get this A inverse matrix. To find the value of this X solution vector, what we do, we multiply the inverse matrix with the vector of constant terms, that is this A inverse B. After that we multiply this accordingly and we get the value of D, S and P, which is 24, 24, 14. Since quantity demanded is equal to quantity supplied, so equilibrium quantity is 24 and our price is 14. Now we will solve the same question using the Cramer's rule method. So in Cramer's rule, the question is same. Given the market model is D is equal to 66 minus 3P, S is equal to minus 4 plus 3P, D is equal to S. Find equilibrium price and output. Now first of all, we will rewrite these equations in such a way that the endogenous variables are on left hand side and exogenous variables are on right hand side. That is to say that the variables are on left hand side and the constant numbers are on right hand side. So I will rewrite this. So here this is D, D, so here it is minus P, this will become plus 3P, so I will write 3P is equal to 66. Similarly rewriting this equation, so here this will become S, here it is plus 2P, so this will become minus 2P, minus 2P is equal to minus 4. Similarly here D minus S is equal to 0. So I rewrite these three equations in such a way that the endogenous variables are on left hand side and exogenous variables are on right hand side. After that we express these system of equations in matrix form. That is, we write them like A X is equal to B, where this A is the coefficient matrix, X is the solution vector and B is the vector of constant terms. So this is here, this A is the coefficient matrix, the coefficients of D's, S's and P's. So we write here the coefficient of D is 1, no S is involved, so the coefficient of S is here 0, and the coefficient of P is here 3. Similarly here D is not involved, so the coefficient of D is 0, the coefficient of S is 1 and the coefficient of P is minus 2. Similarly here the coefficient of D is 1, the coefficient of S is minus 1. Since no P is involved, so the coefficient of P is here 0, multiplied by this solution vector, that is D, S and P, which is equal to the vector of constant terms. The vector of constant terms is these numbers, these exogenous variables, that is 66, minus 4 and 0. So here it is to be remembered that we write the coefficients in order. That is, if we write the coefficient of D first, then the coefficient of S, and then the coefficient of P, we have to go by the same rule. That is, in the second equation we have to write the coefficient of D first, then the S, and after that the coefficient of P. So we can't be the random here. Now after that, what will we do? We take the determinant of this coefficient matrix, that is A. Therefore the coefficient of this the determinant of this A is coefficient matrix. Now the determinant, I have already covered the whole video on how to find the determinant, so I will not go into the minute details. Now what will be the determinant of this matrix is, we take the first element and mentally delete the row and the column in which it appears, and take subdeterminant of remaining elements, that is multiplying these two numbers, that is 1 zeros are 0. Now then we have minus now minus 1 into minus 2 is plus 2, so this will become minus 2. Similarly then we have minus 0. Now mentally deleting the row and the column in which 0 appears, and take determinant of remaining elements, so this will become here 0. Now deleting this column and this row, so here 0 zeros are 0. Now we have minus from the formula. Now 1 into minus 2, that is plus 2, so this will become also minus 2 plus this 3. Now mentally deleting row and the column in which it appears, and taking subdeterminant of the remaining elements, that is 0. 0 into minus 1 is 0, so I will write here 0. Now here it is 1 into 1, that is 1 into 1 is 1, so I will write here minus 1. So this will become now 1 into minus 2 is minus 2. Now minus 0 into anything is 0. Here it is 3 into minus 1, that is minus 3. So our determinant is minus 5. Now after that, what will we do? We will form a new matrix in such a way we replace the first column of the coefficient matrix by the column of constant terms. That is, we will form the second matrix in such a way. So I will write the second matrix is formed by, that is A1 is formed by replacing the first column, this column, by the coefficient of constant terms. So in place of 1 0 1 we write 66 minus 4 and 0. So I will form this. So this will become 66 minus 4, 66 minus 4 0, and these columns will remain same, that is 0 1 minus 1 and 3 minus 2 and 0. Now that is to solve for this D, this first element, to get the value of this first element, we form a new matrix in such a way that we replace the first column by the column of constant terms, and take the determinant of this element, that is A1 is equal to, now taking determinant of this this very matrix, so this is equal to, now here it is 66 now deleting row and the column, and here it is 1 zeros are 0. Now minus, here it is minus. Now 1 into minus 1 into minus 2 is plus, because we have here minus also, so this will remain minus, so this is minus 2. Now here it is minus 0, because the signs get changed alternatively. This here the sign is plus, the sign of the first element is plus, the sign of the second element is minus. Similarly the sign of the third element will be positive, so here it's minus 0. Now deleting row and the column in which it appears, and take determinant of remaining elements, so this is minus 4 into 0, that is 0. Now here we have minus. Now minus 1 into 0 into minus 2 is 0, so we will write 0 plus this element 3, and deleting row and the column in which the this element appears, and taking determinant of remaining elements, so this is here 3 into minus 4 into minus 1 is plus 4, and 0 into minus 1 is 0 into 1 is 0, so I will write here 0. Now this will become Now 66 into 2, that is minus 132. Minus 0 times anything is 0. Here 3 4s are 12. So this is here 12, which is equal to minus 120. Now here we will using the Cramer's rule, using Cramer's rule, that is, to solve for the first element, the value of this d, this is equal to the determinant of the new matrix, that is determinant of a1 divided by the determinant of the coefficient matrix, that is a. Here it is minus 120 and our a was minus 5. Now this minus minus gets cancelled out. Now 5 ones are 5, here 5 twos are 10, here this will become, and this will become 20, that is 5 fours are 20. So d is equal to 24. After that, so this was solving for the first element. Now solving for the second element, we have to form the new matrix similarly. Now this is formed, this a2 is formed by the, this new matrix is formed by, now first we formed this a1 matrix. To solve for d, we have to form new matrix a2. Now this second a2 matrix is formed by replacing the second element, replacing the second column, this second column by the coefficient of constant terms, and taking the determinant of this very matrix. So our new matrix will be 1 0 1. Now in place of this we write 66 minus 4 0. So I will write 66 minus 4 and 0. Similarly this will remain same, 3 minus 2 and 0. After that, taking determinant of this element, this matrix, that is a2 is equal to, now same, we take the first element and multiply it by the determinant of the remaining elements by deleting the row and the column in which the first element appears and taking determinant of remaining elements. So 1 multiplied by, that is minus 4 into 0 is 0. Now minus 0 into minus 2 is 0. Now here it is minus 66, sign changes alternatively. 66, now deleting the row and the column in which it appears, taking determinant of remaining elements. So 0 into 0 is 0, minus 2 into minus 1, that is minus 2. Now minus 2 into minus, that is plus 2. So I will write here 66 multiplied by this very subdeterminant. Similarly here it is minus 3. Now deleting row and the, sorry, it is here plus 3. So deleting row and the column in which it appears and taking determinant of the remaining elements. So this is here 0 into 0 is 0. Now minus 4, 1 into minus 4 is minus 4, and here it is also minus, so this will become plus 4. So this is equal to, now here it is 1 into 0 is 0. Now minus 66 into 2 is minus 132, plus here 3 4s are 12. So here it is also 12. So this will become minus 120. That means S, this S is equal to, using Cramer's rule here also, that is S is equal to the determinant of the new matrix A2 divided by the original matrix, that is A. Here it is minus 120, the determinant of this matrix divided by the determinant of the coefficient matrix, that is minus 5. So here it also comes to be 24. That means quantity demanded, equilibrium quantity demanded is 24. Also the equilibrium quantity supplied is 24. That means our Q is 24. Now we have to solve for this very element, that is P. So I will rub here, I will rub this out. Now solving for this, now to solve for this P, we replace the third element of the coefficient matrix by the coefficient vector of constant terms. That is, the new matrix is A3, which is formed by replacing the third element of the coefficient matrix by the vector of constant terms. So this will become A3 is 1 0 1 0 1 minus 1, and in place of 3 minus 2 0 we write 66 minus 4 and 0. Similarly, taking the determinant of this very matrix, that is A3, is equal to, now this is 1 multiplying it with this 1 zeros are 0. Now here it is minus 1 into minus 4 is plus 4, so I will write here 4. Now here it is minus 0 minus 0, deleting row and the column, we have 0 into 0 is 0 and plus 4. Similarly, now we have plus 66. Now deleting row and the column and taking determinant of this very subdeterminant, so this is 0 into minus 1 is 0, minus 1 into 1 is 1, so this will become this is here 1 into minus 4 is minus 4, minus 0 into anything is 0, plus 66 into minus 1, that is minus 66, which is equal to minus 70. Now to solve for P using Cramer's rule, P is equal to the determinant of the new matrix, that's A3 divided by the original matrix. Now our A3 is minus 70, our original coefficient matrix, the determinant of that very is minus 5. Now this minus 5 minus gets cancelled out. Now here it is 5 ones are 5, 5 ones are 5, and this becomes 5 fours are 20. That means the equilibrium price is 14. That means equilibrium price is 14, and equilibrium quantity which we have calculated, that was rather 24. So this is how we use the Cramer's rule in solving this very question. Actually, I have solved this Cramer's rule in detail. You can see in these videos how I have done this. So here there was no space and time to explain all the details. You can go to my previous videos where you can see the full detail, how to use the determinant, how we replace the first element by the corresponding vector of constant terms. So this all is solved there. So for more videos on mathematical economics, please subscribe our YouTube channel Econ Maths. Also like, comment and share if you like this video. Thank you.